Welcome to the Grasp tutorial. Here we have a third-person template with an additional character, and because we read the How to Use wiki, we already have Grasp installed. Now when we work with Grasp, the first thing we want to do is press Edit, Project Settings, Collision, create a new object channel called Grasp, default response ignore, create a new preset, also called Grasp, collision enabled query only, object type Grasp, and ignore everything. Now we can come into our Grasp developer settings and assign the new profile we made. It might be missing, in which case close your project settings and open it again. And now it will be available. What this means is that every interactable component or graspable component we make will be assigned this collision profile automatically. However, if we restart the engine, our changes will be lost. We must click Set as Default and press Yes on the confirmation boxes. So with that completed, we can also show our plugin content and also show the engine content if you installed Grasp to the engine. And then we can select Plugins, Grasp Content, and we can duplicate Grasp targeting into our project. So expand Grasp selection, and under Collision Object Types, we can change this to Grasp, the object type that we just created. So save that. Now we can set up our game framework. Open your third-person character and add an ability system. Your project might already have one, or you might want to put it on the player state, but we're going to keep it simple for the tutorial. Now create a player controller and assign it to your game mode. Now open the player controller and add a Grasp component. You will see that we have options for a default targeting preset. Assign the targeting data we just duplicated. Now in the event graph, we need to initialize Grasp. Let's add a Boolean property as initialize and take the event on possess. If we have not initialized and we have a valid pawn, then cast this pawn to our third-person character. Set has initialized to true, which I forgot to do at the time of recording this video, and take the ability system that we just added. And now we can call initialize Grasp and pass in the ability system and add a scan ability. Use Grasp scan or create your own. Do not use the included Grasp scan ability. That is a C++ class, and it's not suitable for this because it doesn't have the scanning task assigned. This is a server-only ability, so if you create your own, make sure to change the settings. Now we can compile and save, and we can play. Now we're not going to see anything happen because we haven't added anything to our level to interact with, but we can use debugging tools to make sure that Grasp is running properly under the hood. So open the output log, doc and layout, and type log Grasp verbose. Now, when we play again, we would expect to see logging, but for some reason the filters don't show these categories by default. So press Filters, Show All, and now you can see what happened. It tried to activate, it cached the component, it set up bindings, it had no presets or was waiting, but it hasn't continued to wait, so we can assume that it's running properly. Of course, we don't have to assume. We can look at the scanning that it performs. So p.grasp.selection.debug. So we can see our sphere shape here. We're scanning for interactables, but of course there aren't any in the level. Now, if we create a new actor, we can call it BP Interactable. And this can be our base class for anything we interact with. So create a child, BP Interactable coin, so a coin that we pick up. But we're not going to use this. We're going to do something a bit simpler just for demonstration purposes. If I drag this into the level and I give it a physical representation, in this case a sphere, Now, when something is already in the level, Grasp uses components. It's not actor-based, so we can have multiple ways to interact with the same actor. For example, a door that we can push to open, or we can turn the doorknob. So let's add a graspable sphere component. It gets added. We can change the size. Now the position of this component generally defines where we will interact with it from in terms of our interface. And it also determines where the system will pick it up from as well. Now you can see it's got a red circle. That means there's an error. And we need to assign grasp data, but there isn't any. So let's create some. Miscellaneous, data asset, grasp data. So this is going to be for a coin that we can pick up. So let's assign this. And we get a new visualizer. Now the max grasp angle is based on the forward vector of the component that we can interact with, the sphere that we added. So we will have to be standing within this green arc, or we cannot interact. That means the center point of our capsule must be within this point here. There is also max grasp distance. What this means is that if we're within this range, then the UI should typically show that we're getting close to something we can interact with. However, this hasn't been implemented for you. It is just there for you to use if you wish to. So the inner circle, we must be this close to interact. You can also set the max height above and below. So if we're too far above or too far below the component, we can't interact with it. Everything else will be covered on the wiki. Now if we play again, we can see that we are picking this up. There is another debugging tool we can use, p.grasp.giveAbilityDebug. So we can see if it's giving us or removing any interaction abilities, but nothing is happening, which means we're not giving or losing any ability. And that's because we haven't assigned this to our target data, to our grasp data. An ability is mandatory for the system to function. So let's create a gameplay ability blueprint. GA pickup coin. We can assign it here. And even if we don't do anything, we should now notice something happens. So you can see it gave us the ability. If we leave, it gets cleared. Now if I come a bit closer, you can see there is a percentage. When it hits 0, that means it's going to grant the ability. This means we don't repeatedly run in and out of range while repeatedly granting and clearing abilities, which has a high cost. The reason we do it this way is because giving an ability is not predicted, but activation is. So we have enough time to give the ability before we're close enough to activate it, unless we have absurdly high latency or movement speed. For abilities that are commonly used, such as picking up a coin, we can add these to common grasp abilities. Now they won't be removed while we're playing, and that's represented with a purple line. That means we always have this ability. So now we want to actually interact. We want to activate this ability. However, grasp is not the first port of entry into interaction. A focused targeting system is generally what we would use. You can download Visual for free and set that up. It's very similar. It's made to work with grasp. It's designed for it, but you can use anything that can retrieve this sphere. For the sake of simplicity, we're going to add debug key E, so E the common interaction key, get all actors of class, and BP interactable. And we're just going to assume we only ever have one. So now we need to know what we're going to interact with, and that's not the class, that's the component. So we just go get component by class. We can search for the grasp sphere that we have added. Normally we would get this from the focusing system, which would have the component for us. So if we just drag off and type grasp, you can see what kind of tests we can do. We can test the angle, the height, the range. We can try to activate it. And we can also test if we can interact with any of these. So let's start with can interact with. We can do a switch on the return value. So maybe we highlight it, we draw a widget, or maybe we can interact. So the UI will use the same result to show us what kind of indicator we have. And that indicator can use the normalized distance or angle difference to animate itself. So the interactor has the controlled form. So this is the actual physical representation. It's not our player controller. Now, if we can interact, then drag off here again, grasp, can grasp activate ability. Now this is where it gets interesting. We have multiple ways to send information into the ability. By default, it's called event data. That means that we get the option of using both activate ability from event, which will pass in what we're interacting with. It will specifically pass it into the ability. However, a focused targeting system could also just use activate ability without using custom data to save having to send additional information if you want to. If you use activate ability from event, you must delete activate ability. If it exists on your graph, then this won't work. We can also use should ability respond to event. It is similar to can activate ability. However, can activate ability, the only information it has is here. It does not have any way to reference what we're interacting with. So all we can detect here is our character alive? Are they busy? Are they attacking or something that would prevent us from interacting, in which case return false. With should ability respond to event that we get with the event data, we can test this as well. We can choose get graspable component or primitive. If you use graspable component, you specify which one you want, and it will be that type. Or if you're not fussed, then use the primitive, which can be any of those types. And now we can check the owner of this, and we can check any interfaces they might implement, or we can check the primitive itself for anything. And this, if it fails on the client, it will prevent an RPC from being sent to the server, so it can be a good optimization. So now we can do the same and can activate ability from event. The other option is automatic. It will use event data if we are adding additional optional grasp target data. So we use event data or a focused targeting system, either or. So this graspable primitive is the sphere that we have added here. And the owner is the BP interactable actor. So maybe we want to destroy it when we pick it up. But before that, let's cache this. Get avatar actor from actor info. We can cast this to our character. And we could play a montage. Make sure you use play montage and wait. Don't use the other one. But before we get stuck into that, let's go back to our player controller. And if we can activate the ability, then let's try to activate it. And we want to use the same method, event data. And all we're actually going to do for now is have it print hello, and then end ability. So now if we hit play, you see we've received the ability. If I press E, nothing happens because we need to be within that angle and within that radius. So now we see hello each time we activate it. But if nothing's happening and you want to know why, the first thing I would do is I'd insert print strings here and see where it's failing, and then you can start to narrow down the reason. So now that we have an ability that works, the next thing we want to do is actually do something interesting with it. If we fail anywhere, we should cancel the ability. However, in an actual game, we would have tested every fail case in can activate ability, and if we can't, we would have tested it in should ability respond to event. So it would never fail on any conditions here. Now, let's play a montage. If I take this graspable component and type grasp again, I can choose face toward grasp. So this is an additional node we can use as well, and it will rotate us towards what we're looking at. It's also going to lock us in place while that rotation occurs, and this pairs nicely with a montage. Of course, we would probably use root motion on the montage, or we would use motion warping. But for a simple test case, this works really well. And for a lot of games, even in production, having them rotate towards what we're interacting with can be very quick and beneficial and sufficient. Now we can choose to drive the end of the ability with either. I'm going to drive it with the onCompleted event, as well as interrupted or cancelled. Now grasp includes helper functions. If you type grasp and cardinal, we have functions that will be documented in the wiki, yes, but also if we want to get a cardinal to use for our animation, we can actually grab this here, get their location, get the rotation. So this is our character. And then the target location, we take that from the graspable, from the world location. Now if we insert this in here, we could do a select And choosing montage, so this we could have a jump left, right, forward montage, and this would jump backwards, it would jump forwards, left or right, based on what direction we want to go to either move towards or to get away from this graspable. There are plenty of others to play with, read the wiki. For now, we're just going to play the pickup montage, and all that is a simple pickup animation. So if I compile and save, we come back here, we play our animation and the ability ends. Since we're picking something up, we probably want to actually destroy what we're picking up, and we probably don't want to do it at the end of the animation, so we can use a task wait delay, say 0.4 seconds, but just needs to be before this ends. So we can get the owner of the graphable, and we can call destroy actor, or we can call set lifespan. So if we wanted to do that instead of the task wait delay, that would be better because we're within the same prediction window. And it wouldn't matter if the ability ended either. So let's try that. And now we have picked it up. This can make a callback into our inventory or whatever we want to add an actual coin. So that's the gist of it. That's how you make an interaction ability for Grasp. From there, you can extend it however you like to do whatever you need. And thank you for watching, as always.